If you look at art after the Renaissance, we see that objects that are further away become smaller. In fact, a common experiment is you place a quarter in front of your eye and you can block out the moon or the sun when clearly they're much bigger than the quarter. Furthermore, if you look at something like railway tracks, you'll see that the lines, even though they're parallel, seem to converge in the distance, although they never actually meet. This is perspective projection, where you have a center of projection, which is the camera of the eye location, and the geometry is as shown here. So this is your screen, and the line AB will project onto A prime, B prime. Of course, the further away it is, the smaller it will appear when projected. This is the standard projection model that is used everywhere, not just in computer graphics, and we're going to talk about the mathematics required to make that work. Consider this overhead view of our scene. This is the eye of the camera, so let me note that down. This is the eye. Here we have our screen or our image, and so let's say this is the image. We have some location in the world, x, y, z, that projects to some location x prime, y prime, d. The question is, what are the coordinates of this point? So of course the formulae for x prime and y prime are similar, we can just do one of them. The screen is assumed to be a distance d away, and the world space object is a distance z away. Now the triangles are similar, so this triangle is similar to this whole triangle, and therefore the length ratios should be similar. So I can say that d over x prime is equal to z over x. Let me just write that down. Of course, what I really want to solve for is what is x prime equal to, and so x prime I can bring here, and it will be equal to d times x by z. And so this implies that x prime will be equal to d times x divided by z. This division by z is really critical. That is what ensures that the object gets smaller the further away it is from the screen. And of course, we cannot divide by z using standard matrices, but that's where homogeneous coordinates really become useful, because to dehomogenize, you divide by the fourth coordinate, and one can create the matrix so as to put z in the fourth coordinate. So just bringing this up here, you can say, I just wrote it the other way, I said d by x prime, but one can do it, write it in this form. You have x prime is equal to d times x by z, and y prime is equal to d times y by z. So what does the 4 by 4 matrix look like? X and y values do not change, but we are playing with the fourth coordinate here. So what I'm going to do is that I'm going to try to write this times some x, y, z, w to show you what happens. This will be equal to, so the x coordinate doesn't change, and so we can just write this as x, we can just write this as y, and initially let's say w is equal to 1. Okay, so what happens to z? It doesn't change either. So the only change is in this fourth coordinate, where the w value I've just multiplied by 0, so it's not even relevant, but what I'm doing is I'm taking minus z by d here. So minus z by d. Now if I dehomogenize this, you will see that x will be multiplied times d by z, y will be multiplied times d by z as we wanted, and in fact the z coordinate which I'm going to drop, if you also multiply by d by z, it will be equal to d, which is just a constant, which is where the image plane is. Now, of course, the question is, why is the minus sign? Again, OpenGL convention, you're looking down the minus z-axis, and so the focal plane is at minus d. So again, I went through that verification already. You can do this formula, and it's x, y, z minus z by d. If you multiply it out, you'll get d times x by z, d times y by z, minus d, and 1. And in fact, this is exactly what you want to do in order to get perspective projection working. The next segment will deal with the derivation of GLU perspective, putting together the concepts we've talked about so far for perspective projections to see how the final matrix in OpenGL, with all of its complexities, is created.